Okay, hello everybody. Uh, Today I'm going to be talking about the work that I've been doing for the Alpha Omega uh, uh, group at the OpenSSF for adding build provenance to Homebrew. So, first, to start off, who am I? I'm Joe Sweeney. I'm a security engineer at Trail of Bits. Trail of Bits is a software security research company, and we try to help out with many open source projects as well, including this. And I am also a sailor. So, what is Homebrew? Homebrew is the most popular package manager for macOS. It was originally released in 2009 and has only increased in popularity since then. Maybe to give a show of hands, how many people use Homebrew? Okay, fair number of people. So here are some numbers to give a sense of how widely it is used. So in the last month, we've had about 21 million installs for not Homebrew, but how many people have installed something using Homebrew. And then in the last year, we've had 218 million brew install calls. So very widely used. So before we get too far, Homebrew is going to have some weird terminology that's very specific to Homebrew. So I figured I would go over that and give you a very concrete example in order to, so you can follow along with the terminology. The two big concepts are formula and bottles. So a formula is basically the formula or recipe for how you actually build a piece of software, where it's coming from, where the source code is, any other metadata, and you can see that over here on the left. This formula is specified as a Ruby file, which is then executed and actually is used to build the end bottle. So what is a bottle? A bottle is actually just the binary package that the user actually runs on their machine. So here we can see actually in Homebrew core, you can go to the packages and you can scroll through every single Homebrew core package on GitHub. So that's where all the bottles are hosted, and they're all as just tarballs that get downloaded and unpacked to your machine. So now we're adding build provenance to Homebrew, but what is build provenance? Well, before we talk about build provenance, I'm sure, judging from this morning, I think a lot of people know about build provenance, but here is the highest level overview of the process that software has to go through to go from the source code to ultimately being executed on a user's machine. So along each step of the way here, these are the places where you might have an attacker try to add some malicious code. So we can go step by step through here. We can have a developer that can directly add malicious code to a project. We can have attacker commit new code to an existing repository, either through social engineering or compromising the repository. That's what happened to PHP. An attacker can also modify the build infrastructure to include different source code. Third-party dependencies can be changed out from underneath you. They can compromise the build platform and inject malicious code. So that was what SolarWinds was. Build packages have to be hosted somewhere, so an attacker could upload a malicious package that then users would download. An attacker could host a malicious package mirror, or tap in Homebrew's case, and then serve compromised packages. This is a paper that some researchers done exploring that possibility. And then a user could simply download and use a malicious package, which we're probably not going to be able to do much about, but there was a large case of this happening with somebody naming a JavaScript project something, and then users just downloading it. But ultimately, it's important to note that fundamentally, a malicious developer that is trusted could probably do things at any part of the stage. So the XC backdoor attempt done by a person called Giatan is probably the highest, the first one that comes to mind today. So what can build provenance actually help us with here? Well, really, it's just these two parts. We can stop a package from being uploaded to a package repository and then having a user potentially download that, because we can check to make sure that, oh, was this package actually built in a manner that we thought before it was uploaded? And then we can also check, oh yeah, and it was built by the actual build infrastructure that we expected. The build infrastructure wasn't different. So what does build provenance not help us with? Well, basically everything else. So a maintainer could go rogue and approve malicious formulae. GitHub's infrastructure could be compromised to insert malicious code while building. Many, many things could go wrong that adding build provenance could never help us with. So given that, well, why are we doing it? Well, before we get to that, to answer that question, it's important to understand what build provenance actually includes. So we have here the spec from Salsa, which is kind of, for me, this is a little bit abstract, like what I'm not really sure exactly what an external parameter is versus an internal parameter just from looking at it. And I'm going to get back to that. But before we dive into exactly the contents of the build provenance that we're creating for Homebrew, let's first look at how are the bottles actually built. So I mentioned this earlier, but Homebrew maintains the repository of formulae called Homebrew Core, and the entire building and hosting infrastructure runs out of this repository. So you have additions and updates to formulas for contributors are done by opening up a PR and changing one of the formulae in the formula directory that you can see there. In the PR, the CI builds the bottles. Once it's approved, it is then, the change is then committed to this repository, and then when you go to install a bottle, it's hosted in the packages for this repository. So everything is kind of based out of GitHub. So how are these bottles actually built? Well, at the highest level, these are the steps from a change into a bottle to that bottle being live for a user to install. A contributor starts by forking Homebrew Core and then making some change. Some of this might be automated. There's some various Homebrew tools that help you bump version numbers and such that will generate the PRs for you. So if you go into Homebrew Core and look at the PRs, you'll see lots of them are just auto-generated bumps and versions. So this PR needs to contain one commit per bottle change, which it is actually pretty important because it gives us a very simple tie between the bottle that was generated and what commit actually made that change. So later on, when we're looking at the build provenance for the bottle, as long as we can trace it back to that one commit, we can kind of construct the story of where this bottle came from. So then once you've submitted, the user has submitted the PR, in running the CI, we need to build the bottle to make sure that the bottle is actually working, is actually building properly. And so in this process, that's where the bottle is built once the PR is submitted. And then a maintainer will come along, review the PR, make sure everything looks good, and they'll approve the pull request. And at that point, Homebrew has an automated process that tests the bottle and checks that everything is ready to commit. This automated system is called Brew TestBot. If you're interested, that's the search term to learn more about how this works. And this is what ultimately pushes the final commit, which will make the change to a given bottle live. So how do we actually end up signing them? So in this final workflow, after a PR is approved by a Homebrew maintainer, we have added a GitHub action to this CI infrastructure. So right before the final commit is pushed to live, this is when we generate our build provenance. Some of you'll probably have noticed here, when I'm giving this description, we have the bottle built at one stage, and then later on, the build provenance is actually signed and created. This seems like it would be a problem. Like, wouldn't we want to sign when we build or rebuild again before signing? The trick is, or the insight is that anyone could submit a PR to update a bottle. So many bottles might be coming in and getting built in the CI that might never actually be approved. So we wouldn't want to be generating build provenance for these bottles in case build provenance isn't going to be deleted later on. And so we don't want somebody going and checking and seeing, oh yes, this bottle that was never approved actually had build provenance generated for it. So our trust for build provenance is ultimately falling on Homebrew maintainers. So once a Homebrew maintainer has looked at a PR, looked at a change to a bottle, and said, yes, this is good, this follows all of our guidelines, that's when we'll generate the build attestation. This is also not a problem because of that one change per commit. So we know that the build provenance will point to the exact commit, and you'll be able to go back to that commit and see exactly what the change was to the formula that then generated the bottle. Yeah, sure.
So are you able to generate not a SIG-score signature, but at least an internal checksum from that PR build so that when the person in approval sees that they can validate that they are in fact the same?
We're not doing that yet, but that might be something to add in the future. So, but good question. So how are we actually signing the bottles? So at the start of this project, we thought that we would be implementing a SIG-Store client in Ruby and generating our own attestations from that. But right at the start, we learned that a team at GitHub was beta testing an action to generate attestations for various artifacts, which made this whole process a lot smoother. So you can actually see here, these 4 lines added to a GitHub workflow can be used now to generate attestations that can then be pulled from and verified on GitHub later with just this simple addition. So there was a little bit of infrastructure that had to be written in order to get to this simple addition, but it was very handy that the folks at GitHub came along at just that time when we were starting this. So that made this effort much, much smoother. So finally, we come around to what is actually in that build provenance. So we can start with the subject, which is just the bottle that was produced and signed. We have a link to the spec that we follow, which is the SLA spec that we mentioned in an earlier slide. Then we have our external parameters, which, as you can see, just specifies exactly which workflow was run in order to generate this bottle. The internal parameters specify who ran the workflow, so the repository and who owns the repository. So in our case, that's Homebrew's official repository, which, again, that's kind of our root of trust. The people who maintain and are in charge of Homebrew are kind of the people who we trust to be making changes to bottles. Then we have what was actually used to build it, which Homebrew makes easy for us because of that one bottle change equals 1 commit rule. And then lastly, we have the ID to track down which specific GitHub action run generated this build provenance. So you can then go through and trace back, and this gives you a clear history and auditability. And then you can kind of see from over there, we actually have a command using the GitHub CLI, which you'll see in a second we make use of in order to verify these things. So you might have noticed that this whole story that I've been telling really only applies for bottles that are being updated and changed going forward. So let's say I'm a user and I go and I want to verify that this bottle has a build provenance generated for it. Well, there's tens of thousands of bottles that haven't been updated yet that don't have any build provenance. So as a temporary measure, we went through in our own repository. So we went and generated build provenance for under Trail of Bits Homebrew Brew Verify in our repository that we control. And we actually use this as a backup. So the idea is that now when a user now when a user pulls wants to verify the build provenance, they first check to see if it was officially generated by Homebrew Brew Verify, and then if not, did we sign it? So it's a previously built bottle before we had this infrastructure in place, and if not, then we would actually emit a warning. So I'm going to kind of breeze through this. This is like the hard way to do it, but I don't have time to kind of elaborate the point. So here's how you can use it yourself right now. So we depend on the GitHub client in order to do our verification. You can tap our third-party tap for a command, and then you can run brew verify for a formula. And actually, shipped just last week, you can, if you update your homebrew and have the GitHub CLI set up, you can enable this flag, and then when you run brew install, it'll actually check for the build provenance on any bottles you install. I'd like to, these are the acknowledgements. Want to thank Alpha Omega, the OpenSSF, and Michael Windsor, all the homebrew maintainers that helped, and the GitHub package security team that kind of made this possible. And then, of course, my coworker, Will. Thank you. Here's some links, and please reach out if you have any questions after.